Okay, looks like everybody's entered. Hi, everyone. Again, welcome to the ISR CEPA seminar series on Resilient Pacific. This is our first seminar of the spring semester, and we have a really good lineup. I hope you'll join us. We have it scheduled for every week through, I think, beginning of April. So I'm McKenna Kaufman. I'm the director for the Institute for Sustainability and Resilience, and this is a co-hosted seminar with the Center for Pacific Island Studies. Just as a quick reminder that these sessions are recorded and they'll be made available on the ISR webpage as well as CEPAS's YouTube channel. I'm really happy to introduce our speaker today, and I'll just give a quick introduction and turn it over. But Patrick Kirch, he was born and raised in Manoa Valley and completed his PhD in anthropology at Yale and was able to return to Hawaii and work at the Bishop Museum for 10 years. And he was doing research on the Solomon Islands, Tonga, and Hawaii. And then he went back to the continent and had a really amazing career at University of California, Berkeley, establishing himself as an authority in archaeology across the Pacific, and then came home to Hawaii to join UH Manoa in 2019. So with that, I will pass it to you, Patrick, to talk about vulnerability and resilience in island socio-ecosystems, the case of Mangareva, French Polynesia.
Okay, thank you, McKenna. It's a pleasure to be here today on this very winter stormy day here in the islands, true Kona storm. So you've got my title here. I trust everybody can see my screen okay. I'm gonna page down here. Let's see. I hope this works. Yep, there we go. So I'm an archaeologist by training, anthropologist, archaeologist. And one of the things that's interested me for many years now is the relationship between Pacific Island cultures and societies and the island ecosystems that they inhabit, the dynamically coupled relationship here between natural and cultural systems. And about 15 years or so ago, I started a project down in French Polynesia where we were looking actually at 3 island groups. And I have my cursor here, 2 islands in the Society Islands, the island of Moorea and the island of Maupiti, and then Mangareva way down in the corner of southeastern Polynesia. And I don't have time to talk about all 3 cases. The idea of this project was to compare different island ecosystems to see how vulnerable and resilient different cultures and societies were in different natural contexts. But I just want to focus today on the case of Mangareva, which is a very interesting one. And just to note here on the map, Mangareva is quite far south. It's as far south as Hawaii is north of the equator. So it's a bit of a cooler climate, subtropical. It's not your classic, more tropical islands like Tahiti and so on. And this plays into the vulnerability of the natural ecosystem. And this diagram here, you can see, it just makes a general point about vulnerability of islands. There are many things that make certain islands vulnerable. And by vulnerability, I mean susceptible to change or modification when humans begin doing their land use practices and so on within island ecosystems. But 2 of the key factors are the age of islands and the size of islands. And in general, and we're talking about volcanic islands in the Central Pacific here, I should make that clear. Volcanic hotspot islands like the Hawaiian Island chain and other islands. I'm not talking about the big continental islands like Fiji or the Solomons. That's a different kettle of fish. But basaltic islands, hotspot islands, the older they get, and usually they don't get to be more than about 5-6 million years old before they disappear under the water and become atolls. But as they get older, they lose a lot of the natural nutrients in their soils. And this makes them somewhat vulnerable to human land use activities. And it's, of course, smaller islands are always going to be more vulnerable as well, right, than to larger islands. Small islands where a population can quickly build up and, perhaps have impacts on resource base and so on. So Mongareva is a case here where it's a very old island in terms of hotspot islands, about 6 million years old. And the islands are quite small. There's actually 14 little islets within the Mangareva lagoon, but they total, I think, only about 20 some square kilometers. I mean, you could fit all of them on, basically like on Lanai or something. So we're talking small islands here. Here's a map of the Mangareva archipelago. They call it archipelago. It's really just one big sunken, originally one big island that you would see its footprint of here. But it consists of one main island, Mangareva, as you can see here, another island, Taravai, smaller, and then even smaller islands dotted around this huge lagoon barrier reef ecosystem. Now, one of the things that biologists, when they began studying southeastern Polynesia back in the 1930s, especially from the Bishop Museum, which sent out a team called the Mongorev Expedition, they noted that Mangareva was really notable for the lack of any kind of really native vegetation or animal life on these islands. The plants in particular, it was really devastated. Harold St. John, the botanist on that expedition, I have a quote from him here, said that the islands are desolated. Mostly in the 1930s, the islands were just covered with grassland. So there wasn't really any remaining native forest. There were, of course, cultivated plants. The Mongarevans plant taro in the lowlands of breadfruit, coconut. But this really stood out as an anomaly in Polynesia. And they wondered, why was this, that Mongareva didn't have a kind of, what we call endemic species that, for example, so characteristic of Hawaii, plants that are found only, in Hawaii. And same thing with the insects and the bird life and so on. So it really kind of stood out. And yet there were hints, there were indications that this had not always been the case. And one of the indications was that the expedition found the shells of native land snails in deposits, in soil deposits, quite shallow in various areas around the islands. And some of you may know in Hawaii, we also have, a lot of them gone extinct now, but we had native land snails, the Acatanella tree snails and so on. And Mangareva had not the same species, but very clearly similar endemic land snails, which we find the shells of, but they're all gone, they're all extinct historically. So this gave a hint that maybe at one time the islands were forested with endemic forests, there were snails, there might have been insects. So it posed kind of a puzzle. Why did this island get hammered so badly? Why was it so impoverished in terms of the terrestrial biota? And the deforestation of Mangareva is particularly noteworthy. And the picture you see here, which I took from a little boat going around the backside of Taravai Island, is very characteristic of Mangareva. What you're looking at basically there is just one species of a tall grass, miscanthus grass, that just dominates the landscape. Like that's it. And if you look closely, there's a few pandanus or hala trees. So, this is a very strange environment. And my colleague here at UH, Barry Roulette, some of you may know Barry, wrote a paper with Jared Diamond, the ecologist, a few years ago, looking at deforestation across the Pacific, comparing 69 island societies. And they noted that Mangareva, along with Easter Island, was about the most severely deforested. And so they're asking the question, why did this happen? And I'll try to get to this before the end of the talk today and explain to you why we think this happened, and to just give you a sort of heads up. It's partly the result of human land use, but it's also part of an inherent vulnerability of old islands in this particular situation. So it's not just that people were, causing this willfully. It has to do with certain islands being much more vulnerable than other kinds of islands. Now, if we look at Mangareva in terms of the culture and the society that were existing there at the time of initial European contact, which was in the early part of the 19th century, around the 1820s and 30s is when missionaries, traders, so on first came in. We began to get written accounts of the society. Mangareva is very classically Polynesian in many respects, in presence of Ariki chiefs and many of the cultural practices and so on. But there's some interesting differences. And one of them you can see in this slide is that the Mongarevans did not have canoes, outrigger canoes. How un-Polynesian is that, right? They had these rafts. So you can see this drawing from the voyage of Beechey, 1824, of a group of Mangarevan warriors, tattooed, classically Polynesian, but they're on a raft of how logs. For those of you in Hawaii know the how tree. That's the Hibiscus tiliaceus. It's called purao down in Mangareva. So these logs of how, which will float, lashed together, no outrigger canoes. Now that's really strange for Polynesia, right? Not to have any outrigger canoes. And apparently this had to do actually with the lack of sufficient timber to hew canoes to make them. So they were limited in how they could travel between these little islets. They had to sort of row across on the funky rafts or as little sails. So it certainly limited them. They couldn't go out to the open ocean and do, for example, fishing for aku or ahi or that kind of thing on these kind of rafts. So that's one thing that's really interesting about Mangareva culturally. Also, it's clear that there was no unified political system, that there were different tribal groups that were warring with each other frequently, and the wars had to do with control of land, control of the limited area where you could plant taro in wetland areas, the valley bottoms, and control of the breadfruit groves. These only would thrive in the narrow valley bottoms. They couldn't grow on those deforested hillsides. But on the other hand, so we have this picture from the early 19th century of a place that's, deforested and has some real resource limitations. People don't have canoes, et cetera. And yet, when we look at the marine side of things, not the terrestrial land side, but the marine side, we see a rather different picture. And Mangareva is blessed with this big lagoon and fringing reefs. You can see how extensive in this photograph taken from, I think it's the top of Akamaru Island, looking over toward the main island of Mangareva there in the distance. You see those extensive big reef flats and the lagoon. So the area of inshore marine ecosystem is vastly larger than the area of the islets, the land area of the islets. So this is an interesting contrast. And I would argue that the existence of this very rich marine ecosystem is something that allowed a degree of resilience in the Mangarevan culture and society, that helped them counteract the very limited terrestrial resources in which we're so vulnerable. Now, and just here as an example of that, Te Rangihiroa, also known as Sir Peter Buck, he was a famous Maori anthropologist who was the director of the Bishop Museum for a couple of decades in the 1930s and 40s. And he did a classic study of the anthropology of Mangareva. He wrote a big monograph published by the Bishop Museum called Ethnology of Mangareva. He went there in 1934 with the Mongorev Expedition. And he's a wonderful source of information on traditional Mangarevan culture. And so he writes here that fish did form the principal food supply. And he notes how the areas of cultivatable land were very limited. And when you get into his monograph, reading it, he points out that only certain families controlled taro land or breadfruit land. Those were the chiefly families. The commoners did not have access to that. They had to kind of eke out an existence on wild foods. But the fish and the shellfish and the crustaceans are what made it possible for them to survive. That gave them the resilience. And a result of that as well, he points out that fishermen, fishing experts, had a lot of authority and power, much more than in certain other Polynesian cultures. He comments at one point that by withholding the gift of a fish, a fisherman could bring down a chief. Right? So it's very, very interesting cultural practices. Now, I'm going to show you a lot of data. I'll try to run through it quickly, but I'm a kind of data person. So And as I said, I'm an archaeologist by training. So my work in Mangareva has been archaeological, trying to use the tools of archaeology now to look into the past and see what happened over time from when Polynesians arrived to this contact period that's described by ethnographers and anthropologists. So I carried out 5 different seasons of fieldwork in Mangareva between 2001 and 2014. We're still working up the results of that, hope before too long to publish a volume on all of this. We published a number of articles along the way. But I'll talk about 3 main archaeological sites that we worked on, show them here on the map. One is a sand dune site on Taravai Island, the 2nd largest island, and then 2 rock shelters. These are overhanging cliff type shelters that people occupied, nice places to live in because it keeps you out of the rain and natural places to live. And in each of these, we've recovered our chronological records of human land use and activity. I'll run through them each in succession. So the oldest site, which is Onimea Bay on Taravai Island, you see here. This is the earliest site that we discovered, and it probably dates to the period of initial Polynesian discovery and arrival in Mangareva. We're lucky to find this. Finding sites of that period can be difficult, but it's a little bay on the sort of backside of Taravai from where the main village is. And in 2001, on a reconnaissance going around a small boat, we stopped and I could see this eroding, what we call a midden deposit, a cultural deposit built up by human occupation. And we put a test pit down, you see there. So the gray, see if my cursor shows here, this gray is the cultural occupation layer overlying these yellowy orange sands, which Onimea means actually orange-red sand. By the way, this bay has a very unique sand. And right at the interface, to stop that, there we go. Right at the interface, we were able to get a radiocarbon date here from charcoal right around 1000 to 1030 AD. And this is right around the time period now that all the recent work in Polynesia suggests that Polynesians were rapidly voyaging, discovering, expanding through eastern Polynesia. We went back in 2005 and opened up more area in this site. You see views of our excavation, including a big earth oven, Emu here, very classic Polynesian earth oven. And we obtained a series of radiocarbon dates from the site that allow us to pin down the occupation at Onimea, beginning possibly as early as 950 AD up to about 1250 or so AD for a first layer. At that time, the site seems to have been mostly a campsite rather than a permanent village. And among other things, people were exploiting seabirds who were nesting on the island. Get to that in a second. And then there's a second layer above that, shorter in duration, where it looks like it was more of a permanent kind of a fishing encampment. And that's indicated, for example, by these kinds of artifacts, fish hooks made from pearl shell. It's really beautiful, large, classic East Polynesian fishing gear there. What was really interesting in Onimea was the presence of all these bird bones. So now I mentioned that historically, the bird life in Mongorev is very, very limited. In fact, when you go down there, it strikes you how few birds you see compared to if you've been in other islands like the Society Islands or the Tuamotus, and you see seabirds all the time flying around. Mongorev, you don't see much. And yet, in this Onimea site, in the period dated to initial Polynesian occupation, we had all of these seabirds. And I'll show you, you can see in this picture, some of them here, like the beak of a shearwater. Where's my cursor? Cursor doesn't want to be there. Anyway, you can see that beak. And when we went back for the expanded excavation, even a bit later, we got over 1,000 of these bird bones. So we had experts at the National Museum down in New Zealand, Te Papa Museum, Wellington, identify these for us. And here's a list of the most common birds, mostly seabirds, as you can see, petrels and shearwaters. Again, these are very rare today. And in fact, the most common in terms of the bones in that site was this pseudo-bulweria, species of petrel, which doesn't occur anywhere in this part of the Pacific today. It's limited to subantarctic islands. And yet it was obviously very prevalent in Mongareva at one time. It's the most common species represented in these bones. And we also have these terns and noddies. And then even, you see in the lowest layer there is ducula. So these are fruit doves and pigeons. So these are actually terrestrial birds. They're probably endemic species that had evolved in Mangareva. Of course, went extinct at some point. So we're getting a picture of now of an island ecosystem that 1,000 years ago was very, very different than it has been in historic times, with probably big nesting and roosting populations of seabirds, and then even endemic native land birds such as these doves and pigeons. And some might ask, well, these bones in the site, are they naturally deposited, or are they the result of human activity? And we tested this by looking at fracture patterns in the bones. So if the bones were just naturally deposited, if the birds were just dying of some natural causes, and then their bodies fall down and the bones get incorporated into the sand, you wouldn't expect any breakage patterns in the bones. But if people are eating birds, and think of you eating a chicken, whatever, you're gonna gnaw on them and break them and so on. And this is in fact what we found, is that the large percentage of the bones actually show these fractured patterns. So it's pretty good evidence that people were actually taking the birds for food, right, and consuming them at the site. Now, so that's the Onimea site, and it gave us this window on the very early period with, again, this very different kind of ecosystem with lots and lots of birds, especially seabirds. And I'm going to get to the significance of those seabirds before the end of the talk, because they have a very important role to play, or had an important role to play in the natural ecosystem of Mongareva. The second site that we worked on is on the little island of Ongakawitai, which is near Tanavai. We found this rock shelter, we call it Onga 3, Ongakawitai 3. As the slide mentions, during the Bishop Museum's Mongorev Expedition in 1934, the famous archaeologist Kenneth Emery had spent a lot of time on Ongakawitai. And back in the 30s, their methods of excavation were incredibly crude by our modern standards. They basically just kind of shoveled out deposits on a hunt for artifacts. Didn't pay attention to context. The radiocarbon dating hadn't been invented. So unfortunately, Emery kind of destroyed the best of the sites, but we did find one rock shelter that he had missed, fortunately. And so we were able to work on that site. It's a very small little shelter, just the overhang, as you see on the cliff there. And we, I guess it was in 2012, I think, one of our expeditions there, we did a fairly extensive excavation within this rock shelter. And this one doesn't go quite as far back in time as the Onimea site, but it picks up where Onimea sort of overlaps with Onimea and then takes us through the later part of the Mangarevan sequence. So it's very important. Here's a trench that we excavated down to the base of the site, down to the pre-human period. Fairly deep deposit, as you can see, with several layers there, and what we call the stratigraphy, or the layering, is shown in the diagram. And the radiocarbon dating for this site is shown here with the beginning of occupation with these two dates, down around 1300, late 1200s, 1300. So again, picking up where Onimea stopped. And then a lot of the main deposit in the site is here in the 1600s, and the uppermost layer does go overlap into the period after European arrival. Again, we have evidence of fishing and fishhook manufacture with these pearl shell fishhooks, now a little bit different style, smaller hooks, not like those great big ones from the early period. And then files from branch coral used to manufacture hooks, and some other kinds of artifacts, including what appear to be thatching needles out of bone, and fishing weights, stones with grooves on them for probably net weights, And then here we have from that uppermost layer in the post-contact period, St. Christopher medal. So the Catholic missionaries converted the Mongarevans in the 19th century to Catholicism. That's a whole nother story, but and then we've got a little testimony to that there. Now, when we look at this site, Angakawitai, and the next one I'm going to talk about, Kamaka, these are actual occupation shelters where families lived and carried out full range of domestic activities. So from these sites, and I'm not going to talk about that, but I want to talk about the evidence for exploitation of resources, particularly the marine and the terrestrial. So a lot of fish bone in the Angakawitai site. Here are all the species that we identified from the bones. You can identify fish bones down to the species of fish. And this is just the total, we call it NISP. It's just numbers of identified specimens. And you'll see that it's just a couple of species that dominate the parrotfish, the scarids, and then these are some big groupers here, Epiphilus, and some other, these are wrasses. But so when you get, basically people were eating primarily parrotfish and groupers, and then, taking small numbers of lots of other kinds of things, but those two things really dominated. Now, if the taking of fish in a particular place is very concentrated over a period of time, people are like fishing an area hard, right? Hitting it hard. What will happen over time is that the sizes of fish that you catch will become smaller and smaller. It's a phenomenon that archaeologists who study faunal remains refer to as resource depression. Now, if you think of like Oahu today, I don't know how many of you are attending this are fishermen, but if you think of Oahu's horribly fished out because we have just so many people on Oahu and everybody wants to go fishing. And for the most part, there's no controls, right? Except on Ama Bay or a place like that. So, you get just tiny, manini fish, as we say, literally maninis, but figuratively, metaphorically, manini, small fish. So we wanted to know if that was a case in Mangareva. If Mangareva had a lot of pressure on resources, do we see evidence for decline in the size of fish? Do we see resource depression? So one way to get at that is to measure the size of the vertebrae, right? As the vertebrae diameter correspond to the length of the fish. And we did that. We measured vertebrae, and these are the by layer from the oldest to the youngest, and showing you the 1 standard, 2 standard deviation ranges. Well, you can eyeball, you can see there's no real change. There's nothing statistically significant. So the answer is no. Okay, and this gets back to the point that the marine resources were so rich in Mangareva. The island's so small, you probably never got a human population large enough to really impact the resource base. So again, this is a case where there's a degree of resilience allowed by this really rich, extensive marine ecosystem, okay? With the birds, and we saw in Onime, we had evidence of lots of birds of different species that aren't there today, lots of bones. In the Angikawitai shelter, we sort of pick up where Onime left off, and we go downhill from there. I'm having trouble finding my cursor, but here it is. But so in this case, this is the oldest, layer 4 down to the historic period, and these are the number of bird bones, and you see they just decline precipitously till we get almost no birds in the upper layer. So this is an indication that in the terrestrial realm, unlike the marine, things were really changing, and the bird populations of the island were declining precipitously. By the, say, 14 or 1500s, we had almost no bird bones being deposited in this site. Another thing that we did was to look at stable isotopes of carbon and nitrogen in the bones of rats. So we get this little Pacific rat, the Iole in Hawaii, Kiore and Maori, came with Polynesians everywhere. It's a little Rattus exulans, kind of mouse size, but it's actually a true rat. And these little rats, they live around houses. They're what we call commensal species. They're living off scraps that people, the garbage and so on. And so they kind of are representing human diet as a proxy indirectly. And by measuring the carbon and nitrogen in their bones, Jillian Swift, who was my PhD student, she's now curator at the Bishop Museum in Honolulu, She specializes in this stuff. She was able to see that the nitrogen levels in these rats were declining over time as we went from the earlier to the later deposits. And this is very interesting because nitrogen is an indication of trophic level in ecology. So the higher you're feeding on the food chain, the higher your nitrogen values. So these rats, they were feeding lower on the food chain over time, and probably means that humans were feeding lower on the food chain over time because the rats are basically eating human scraps, if you follow my logic here, okay? And we'll get back to the significance of this in a minute too, but this probably correlates with the decline in the birds, not so much on the eating of birds, but the role that birds were playing in bringing nutrients in as seabirds to the ecosystem. And another line of evidence from the rock shelter directly related to the terrestrial environment was that of charcoal. So when we excavate these sites, we get lots of pieces of charcoal, of wood that people were burning in their earth ovens and their hearths and so on. And this, they're gathering this wood from around the sites. So this gives us an idea. We can identify and quantify enough pieces of charcoal of what the vegetation was like around these sites. We use all these different kinds of evidence in archaeology. We're basically, archaeologists are garbage collectors, right? We're analyzing old people's garbage. Well, we do it in a very detailed way. So you can also identify charcoal to the species of plant by looking at its anatomical structure. And Emily Dott, who's a specialist in this, she worked on the project with us. And this chart just summarizes in terms of indigenous species of plants that would have been there naturally, Polynesian introductions, so things like breadfruit, for example, or the key plant, the cordyline plant, and then historic period introductions, that would be things like mango, which weren't there, in Polynesian times. And you can see from the oldest layer here, dominated by indigenous trees, whatever, but some Polynesian introductions already there. Middle layer, we start to get less indigenous and more Polynesian, and by the top layer, it's dominated by Polynesian introductions, and we begin to get some historic things as well. So it's showing you the transformation of the vegetation on the island from native trees to dominated by introduced species, particularly like breadfruit, for example, and the mountain apple, that was another one. So again, the transformation of the landscape. The last island, try and get through this and leave plenty of time for questions. The last island that we worked on, last site, it's a little island of Kamaka. This is one of the smallest islets and down the most southerly in the Mangarevan lagoon area where it's more open to the open sea coming in. But right with this is one little beach, you can see it here, and behind that lovely rock shelter. Kamaka Island today is one of the few places where you do see some seabirds because it's basically unoccupied. There was one man who owned it, Tihoni Reason, passed away a couple of years ago now. He was the hermit of Kamaka, and he hosted us. So he was a wonderful guy, and we lived with him just outside the rock shelter in his little hamlet there. Anyway, these pictures, you can see there a frigate bird flying overhead at Kamaka, but very remote little chunk of rock, basically. And there's an interesting tradition about Kamaka that I pulled out of Terangi Hiroa's Ethnology of Mangareva. And this is a tradition of one of the famous warriors of Mangareva, Moria Tararoa. And Moria Tararoa was fighting against what they call the king of Mangareva, the high chief of the main Mangareva island. And he gave this speech, which Hiroa's informants told him about, and he wrote down, and which he said these famous lines. He says to Mataira, the chief, says, "Look inside my stomach. All you will see are the legs of land crabs from the rocky promontories of Kamaka." And he's basically referring to this late period of food stress. It's really clear in all the oral traditions how stressed for terrestrial food a lot of the people were. So he's basically saying, all I've got to eat on my little island of Kamaka are these land crabs, right? I'm chewing on their legs. I mean, he was exaggerating, but he's making his point. And in fact, in the traditions, he was getting ready to leave Mongorev completely. He and his family there in Kamaka were preparing for a voyage to try and go somewhere and find another island that was more conducive to human occupation. So anyway, this large rock shelter, this is just a section showing its relation up to the beach. It was a classic site in Polynesian archaeology. It was first excavated by Roger Green in 1959, one of the very first excavations in eastern Polynesia. They called it Kitchen Cave because Roger and his crew camped out and used part of the cave as a camp kitchen, while they dug in the other part of the cave. And the part they used as the kitchen was still intact. So we were able to go, and we did this test bit in 2012, and then we found the deposits were still intact. In 2014, we went and expanded it to about 6 square meter excavation. In the plan here, you see where Green dug in 1959, and then our excavation here in 2014. So beautiful site, deeply stratified. There's Tihoni Reason. He brought out his little Honda generator. This is the winter time. It's kind of dark. And he's a great guy. He had this generator strung up an electric light for us. So we were actually able to see what we were doing. And that's Guillaume Moll, who is now at the Australian National University, a collaborator in the project, who did most of the digging. So you can see it's a very deep, beautiful stratification, the kind of thing that get archaeologists all excited. But this site we have dated very extensively. It's we used radiocarbon. The latest methods are very tight radiocarbon chronology, as you can see here. So this site again is much like Angakauitai, is beginning around 1300 here, and then we have all these dates going through up to, again, the early contact period. And in this case, we also applied this new method of coral dating with uranium thorium dating, was even more precise dating. We just published an article on this a month or so ago, combining all this together. So we have a chronology for this kitchen cave that's one of the tightest now anywhere in Polynesia. But again, what's of particular interest today is the faunal remains. So again, with bird bones, much like in Angakauitai, we get in the deepest parts of the site some birds, and then it just pretty much disappears. It matches Angakauitai. We get a lot of rat bones in the late. This is the late occupation, and this appears to be a time when the site was intensively occupied, probably by Moria Tararoa and his clan, actually, at that time period. And so a lot of people there intensively occupying, and so a lot of rats, because there's a lot of food scraps for the rats to eat. And we did get some beautiful fishing gear artifacts, actually about 60 pearl shell fishhooks out of that site, just to show you that. But when we look at the fish in the Kamaka site, again, this is the total numbers of fish bones. Again, that layer 3 has the greatest number because that's the period of intense occupation. The picture is very much like in Angakauitai. Again, parrotfish, and in this case, the serranids dominating even though you get all kinds of other numbers, these two taxa are dominating. And so again, we looked, is there evidence for resource depression with the fish on Look at the fish vertebrae sizes across the layers. There's a little dip sort of in the middle, but nothing statistically significant. Recently, a PhD student in Tahiti, Vahini Rurua, completed her dissertation on a more detailed analysis of the fish bones, and we provided to her all the bones from Kamaka and Angakauitai. And she does have, with the parrotfish, which is this diagram here, evidence possibly of some resource depression. As you go from the oldest, in this case, the oldest is my cursor, or on the left here, trouble with the cursor on here. So the oldest are quite larger, as you can see. And then in the middle periods here, including the intense period when Moria Tararoa was probably there, much smaller fish. And then we get a rebound in the post-contact European period after the island was probably mostly abandoned. So that is some indication that at least with the parrotfish inshore, there might have been some resource depression. But with the other species of fish in the site, there's no indication. The other three you can see. So again, the marine ecosystem seems very resilient in this case. And we also looked at the shellfish. The main fish, shellfish that were being taken are Solana, the opihi, these little naritas, we call them pipipi in Hawaii, and then these big turbos. And again, looking at size ranges, we don't see any real evidence of resource depression in the marine ecosystem. We also analyzed pollen out of the site to look at vegetation change. And the pollen sequence shows, again, some real serious changes in the vegetation going in the late period to basically that kind of grassland environment that I showed you in the slide early on, from more of a native vegetation to this sort of grassland ecosystem. And Emily Dodd has also done a charcoal analysis very similar to the Angikawitai results, going from indigenous to mostly Polynesian introduced species. I'm not talking a lot about artifacts in this talk, but I wanted to throw this in. This is an adze, or Hawaii we call a koi, toki in Mangarevan, groundstone adze, woodworking tool. When we analyzed the adzes from Kamaka 1, Kitchen Cave, what we found is a number of them match a rock quarry source on Pitcairn Island, which is, I think 800 and some kilometers from Mongareva. It's that really remote island that the Bounty mutineers ended up on. And so this is indication of communication between Pitcairn and Mongareva at some point in time. Now remember that at the contact period in the 19th century, all they had were these how rafts. No way you're going to get to Pitcairn on a how raft, right? So this is an indication of a period when they did have voyaging canoes. They had probably outrigger or even double-hulled canoes. And we're going back and forth between Mongareva and Pitcairn and probably Henderson. Okay, so I'm trying to wrap up in about 5 minutes here so we have time for questions. So why was Mongareva hit so hard? Why was it so deforested? Why did we end up with these grasslands, which we don't see on other Polynesian islands, even though they're kind of similar economic systems of agriculture? Well, I think one key reason has to do with the age of Mongareva. And as I mentioned, on these basalt islands, this is true in Hawaii. Well, this has actually been worked out primarily by Peter Wojtuzik, the ecologist from Stanford, but it applies to all these basalt islands across the Pacific. Phosphorus, which is a very key element for plant growth, derives out of rock, out of the volcanic rock. And after about 1 million years, the phosphorus is largely leached out of the original soils, right? And so, as Wojtuzik has shown in Hawaii, on the older islands like Oahu and Kauai, what's really important is either erosion in valleys providing fresh rock, or on Kauai, this is really clear up on Waialeale, it's dust blowing in from Asia, right, that settles down on the islands and provides a nutrient source to feed basically those plant ecosystems. Now, if you look at a map of the distribution of dust across the Pacific, it's Asian dust, as I get my cursor to work. So here's Hawaii, and the contours here are showing you, the quantities of dust. I'm not sure in what measure that is, but coming off the Asian continent out to Hawaii. So Hawaii still has quite a lot of Asian dust. Mongareva is down here with 1/10 or less of the amount of dust that Hawaii gets, okay? So it wasn't getting that supply, and it's old. Mongareva is as old as Kauai and Niihau. So we have this indication that the islands were forested, they had this natural biota. It was the birds, right? This is what we think. These seabirds that before humans came were there in probably the tens of thousands, if not the hundreds of thousands. These pseudo-Boweria petrels, the shearwaters and so on, roosting, nesting in Mongareva, they were like conveyor belts for nutrients. They go out to sea, they fish, they get birds, they come back, they roost on the land, and they deposit their kukai, right, their guano on the land. So they're a source of nutrient input to these old ecosystems. What happens is after people come in to these small islands, and either by actually taking birds for food, which they clearly did in some cases, but just by clearing the forests on the small islands, and that destroys the habitat for the birds, right? So the birds are disappearing over a couple of centuries for a variety of reasons. And even rats may have been predating on them. But so you break that chain, you're breaking that source of nutrient conveyance from the ocean onto the land ecosystems. And this is why these places like Mangareva is so vulnerable to human action. And again, just briefly mentioning Gillian Swift's work on the nutrient supply, and this is where we have another line of evidence with the decline in nitrogen levels in all of these sites is very, very clear. And this is probably a reflection as much as anything in the declining input of nitrogen to the ecosystem from the seabirds, right? And it gets reflected in the little rat's diet. And the rats themselves, this is a point that's been of some debate, they may also have played a significant role in the deforestation. This has been argued for Hawaii, for example. The little Polynesian or Pacific rat, it's very omnivorous, and it may have been munching on seedlings of plants, on the seeds of native plants. And so it's not just humans directly themselves that are necessarily causing this ecological change. It's animals that come with them, in particular the rat. And then finally, I just want to mention again this connection to Pitcairn and Henderson. Marshall Weisler, who worked out on those islands, archaeology there 20, 30 years ago, noted evidence for oven stones and other objects from Mongareva coming into Pitcairn and Henderson. These islands were known to have had Polynesian populations on them, pre-European. By the time that when European voyagers came to these islands, they were abandoned. There were no longer any Polynesians living there, but they found the traces in terms of temple remains, stone statues, and so on. And Marshall argued that it was probably voyagers from Mangareva in canoes regularly who came out and supplied these little islands and were probably bringing back things that they wanted, like possibly turtles, which laid their eggs on Henderson, red bird feathers, and things like this. Once Mangareva became deforested to the point that you no longer had timber trees sufficient to build canoes, and they had to go to those rafts, what Marshall suggested is that this system collapsed and these islands became completely abandoned. Well, they became cut off, basically, right? And you could no longer have those long distance voyages. So it's interesting that this affected a larger system through the southeastern Pacific, not just Mangareva itself. So I've run a lot of data past you, but I basically tried to show you that this is a case where we had a particularly vulnerable terrestrial ecosystem because of the age, because of the small size. And so when people came in, they set up a series of changes that over the centuries kind of directed the course not only of the island's ecology, but of their own culture in certain ways, right? So that they ended up, for example, with this importance of fishing. But at the same time, the marine ecosystem being so rich did lend an element of resilience here, right? Without which it would have been in much worse of a shape. And I want to be clear, I'm not in any way implying that the Mongorevan people were some sort of eco-vandals that came in and, willfully destroyed the ecosystem. That's the case at all. I think they were just practicing land use practices, agriculture, so on, that they had done or their ancestors had done throughout the Pacific. But they happened to hit an island in Mangareva that was particularly vulnerable to these kinds of land use. So they weren't planning to do this in any way. But because of this inherent vulnerability, they ended up in this situation in the late pre-contact period where, for example, they couldn't voyage anymore. They didn't have the trees, where terrestrial resources were quite limited, and it had all kinds of implications for their culture and society. So with that and a view of the sunset from Kamaka Island, and I just want to, of course, acknowledge this kind of research takes a whole lot of teamwork, and many people have assisted me in this. So I don't want to take sole credit for it. Okay, so we have at least maybe 12 minutes or so for some questions.
Thanks, Pat. That was so interesting. And I can see that we already have questions coming in through the Q&A, which is great. So just a reminder for everyone, if you have a question, please type it into the Q&A. We'll be using that function rather than chat. So let me just dive into this. Moria Tararoa was actually a for Mataira, to whom he refused his services. My question is to do with the non-existence of Vaka Va'a in Mangareva. However, there is the Te Rangihiroa's ethnology of Mangareva, the mention of the destruction of all war Vaka by Mateau, as to put an end to the intertribal wars. And he also mentions that for the ceremony of presentation of the king's daughter for wedding of haircut was done by traveling from island to island on Vaka. By the way, there is an unusual word for Vaka in Mangarevan, and it's Kamiya. The lack of hardwood might have been the result of overexploitation of wood, which seems to be the same case in Rapa Nui. If you could comment on that.
Yeah, thank you. That's a very good comment. I don't know if I have anything to really say. I mean, clearly there were Vaka. They had the term, and there were Vaka at one time. And I think, yes, over-exploitation, probably of things like that tamanu with the big calophyllum tree, which is a key tree to make the hulls of the canoes, resulted in this.
Did you find in your research on the island some significant nuclear fallout due to the 30-year nuclear tests?
Well, that's not a subject that I work on, but we certainly saw evidence of all this, there. I mean, there was, we arrived, I guess it's torn down now, but when we arrived there in 2001, there was still this huge structure that the French had built. It's like the size of 2 football fields, just this giant like warehouse structure into which they moved all the people when they would do the testing on Mururoa, which was, kind of bizarre. And landing, when you fly down there, the plane, it's a long flight. It's like 4 hours or more from Tahiti, and you often land for refueling on Hao, which is where the French had their big military base, for the testing of Mururoa. The whole thing, I mean, it's really kind of bizarre. You see this huge facilities and all this kind of stuff. But I work on old stuff, so I don't have any evidence on the radiation or that sort of thing. We did wonder whether the fallout might have affected some of the radiocarbon dates, but I don't think that actually was the case.
I'll quickly interject one of my own questions. And I was wondering if you could talk a little bit about the change in population in Mangareva over the time period you were looking into, right? So the 1000 to 1800 AD approximately. How did the population arc go?
Getting at population numbers in the past, in pre-contact times, is very difficult. And I don't have a good handle on it from Mangareva. I mean, one would suspect that population is just theoretical. It probably increased fairly rapidly in the first few centuries, and then probably reached some kind of an equilibrium on small islands like this. It may then have fluctuated depending on, ecological conditions, droughts, that sort of thing. But to be honest, we don't have a really good handle. For Hawaii, we've done a lot more research on that, and we have a better way to get at it. And that in some areas in Hawaii, we can date and then count numbers of house sites, which gives us kind of a paleo census sort of method. But we don't have that in Mangareva. So honestly, I wish we did, because that would be a really interesting variable to look at.
Thank you. I'll go back to the Q&A. In the Western Pacific, some islands that didn't have large trees traded for them with other islands that did. Was that not an option for Mangareva?
Yeah, well, in the Western Pacific, you have much larger islands with forest resources on them that are close by. Mangareva, the closest islands to Mangareva are the Tuamotus, which are atolls, which typically don't have, forests themselves either. Though in the Tuamotus, they did very carefully cultivate and manage things like tamanu to make canoes. Interestingly, in the Tuamotus, you get the construction of canoes with sewn planks, because they couldn't get big enough trees to make solid hulls out of single logs, right? So they're really sophisticated about cutting and fitting planks together and make these sewn plank canoes. But Tuamotuans are probably guarding their timber for their own canoes, and not particularly inclined, I suspect, to trade a lot of their scarce timber away to the Mongarevans. And anyway, it's quite a voyaging distance between them.
In Hawaii, kapu was a way to control resource management. Did this concept come into the understanding of your research that you found there?
Yeah, the use of kapu, is widespread in Polynesia for resource management, and I'm sure there's some extent that was applied also in Mangareva. Tahiti is referred to as Rahui rather than Kapu. But so we have the management of resources, for example, putting out Rahui on, for example, a species of fish for a period of time for the stock to increase and so on. So this is certainly, widespread practice throughout Polynesia, and I'm sure was applied in in Mongorev as well. But it doesn't mean that with small vulnerable islands, you can completely overcome the limitations simply by using these kinds of conservation principles.
And from Alex Maurer from CEPAS, many thanks, super interesting. Appreciated the marine resource focus. With persistent ciguatera, one of the other long-running conversations around the lagoon from the 19th century to the present, is there an archaeological signal for this lagoon dynamic?
Yeah, that's a good question, Alex. So Mangareva is really noted today, and I guess has been for some time, for ciguatera. And that I do have personal experience of, because I ate some poisson cru, raw fish at one point that our hostess had prepared, and I got a case of it. Not really heavy, but I mean, it wiped me out for a day or so. Let me tell you, it's not pleasant because it affects your central nervous system, and nauseous and just aching and all that. So I wouldn't want to get a really serious case of ciguatera, believe me. Unfortunately, the answer is we don't know what the pre-contact period. I don't know of any way to detect it. I don't know that nobody, as I know, has figured out a way to see if it persists in bones, if there's some chemical signal of it or whatever. And I'm very curious about this myself. And I wish I knew whether ciguatera had been a factor in the past or not. As Alex, I'm sure you know, because you work there as well, people in Mangareva have a pretty good way of knowing which fish have ciguatera and which don't. I mean, it's very interesting to watch them sorting out fish. They go fishing. This one no good. This one's okay. So on. Although they don't always get it right because, Benicia made sashimi out of this one, and certainly it had some ciguatera in it.
And we can look at one last question. Do you analyze the meanings about Mangarevan toponyms before your research?
I have not done a detailed study of Mangarevan toponyms. It would be interesting to do, absolutely. Is there some particular, I'm wondering if there's some particular sub-question to that the questioner has.
Okay, well, Albert, I'll invite you to chat that in if you want to add to your question, Albert. And also, I want to acknowledge that Anna has added population numbers into the Q&A.
Yeah, I'm seeing that.
Temporary numbers and PhD.
And that's, of course, from the historic documents, though I see something seems to be wrong there with some of those. There's some really large numbers early on that I'm not sure whether being repeated or something. Anyway, I would imagine, I see we're looking at numbers, well, Beachy estimates 1,500, and you've got 1834, 2000, I think 40. And those seem to me to be reasonable numbers for kind of maximal population at contact, given the small size of these islands and the limited terrestrial resources, the amount of area, land in cultivation. Something we're working on right now is to try to do a quantitative model using GIS of the likely range of population that could be supported given the known land area of certain land use types, what we know of average productivity, for example, of taro, breadfruit, and so on. So we've got Cedric Pulston, who's a quantitative modeler, is working on this, and it may give us a theoretical idea at least of what maximum population and ranges may have been based on what we know of the land use types and what plants and so on we're cultivating. We're factoring in the marine as well, the protein sources on that.
Seems to me like that would be a kind of a similar methodology to what I've seen in Natalie Kuroshima's work for Hawaii.
Yeah, it's very similar to what Natalie was doing. Natalie she got her start, as an undergraduate at Berkeley working with me.
Oh, I didn't know that.
Yeah, her undergraduate thesis there on modeling colluvial slope agriculture in Molokai. I was her advisor, and then we actually co-published that. And I'm of course delighted to see now she's gone and made a whole career, expanding that whole line of work. But yeah, that's essentially the same kind of thing we're trying to do for not just Mangareva, but Maupiti and Moorea Islands, the 3 islands that we've been looking at comparatively.
Awesome, very interesting. Well, we are at time, and I want to sort of respect everyone's time commitments, but before we close, Pat, I just want to give you the opportunity to have one last comment, anything you want to end with?
No, just I said, I think, this kind of comparative analysis of ecosystems, cultures in the Pacific, it's of inherent interest, of course, historically to know what happened on these islands. But I do think that there are implications, more widely for what's going on in the world today, and lessons to be learned, obviously. So I hope that, the work is not just, historical interest, but more broadly. I guess I would end with that comment.
It's great. Thank you so much. Next week, I just want to invite you to hear Joy Enomoto, who will be joining us, everyone. So hopefully we'll see everybody back next week. And thank you so much, Pat. That was great.
Great. Thanks for inviting me.
Appreciate it.